Hi, hello everyone. Welcome back to ANR Academy. Today I am here with you to discuss about two special inequalities. They are first one, minus of modulus theta, which is always less than or equal to sin theta less than or equal to modulus theta. This is first result. And then we will discuss the second one, minus of modulus theta, which is less than or equal to 1 minus cos theta less than or equal to modulus theta. You people are familiar with the inequalities minus 1 less than or equal to sin theta less than or equal to 1. But here the special is modulus of minus theta less than or equal to sin theta less than or equal to modulus theta. And we know that cos theta always lies between minus 1 and plus 1. But here you have 1 minus cos theta also in between minus modulus theta and modulus theta. Let us discuss these two results today. I am going to select a unit circle. Suppose that there is a unit circle x square plus y square equal to 1, x axis, and this is y axis. I am going to select a general point P on the circumference. This is origin. O to P, the distance is here, radius of the circle. Suppose that radius is 1 unit. Since it is unit circle, the equation x square plus y square equal to 1. This is positive x axis and this is y axis. If you drop a perpendicular from point P to x axis, then suppose the foot is capital M, then you know that horizontal component, this is known as cos theta, and this is vertical component sin theta. Why? Because this is of unit radius. Coordinates of P written as cos theta comma sin theta. You know all these. On the same diagram, let us observe. Here it is the distance P to A. Observe the distance P to A. It is length of arc. And here the angle made by OP with positive direction of x-axis in the counterclockwise sense, it is clearly theta. I am going to write distance AP from the figure. From this figure, AP length of arc formula L equal to R theta. So the length L AP is clearly theta. Why? Because radius is 1 unit. Due to 1 unit radius, clearly this length is theta. And observe here P to M, the distance. It is clearly less than length of AP. PM length is less compared to PA length. And suppose P coincide with A, then equality holds. So I can write PM, which is less than or equal to theta. And now from the triangle PMA, see from the triangle PMA, it is a right angle. I am applying Pythagoras theorem. This PMA, hypotenuse PA, height PM, base AM, so that we get PM square plus AM square, which is equal to PM height, AM base, and AP hypotenuse. It is equal to AP square. And here AP is clearly theta. PM, which is less than or equal to theta, and also AP. AP also, AP line segment it is, AP arc length it is, AP line segment which is also less than or equal to theta from the figure. So that I can write PM square plus AM square, which is less than or equal to, here AP is line segment, length of the line segment AP, which is less than or equal to theta, and hence I can write AP square less than or equal to theta square. Here AP is arc length theta, here AP is line segment length always less than or equal to arc length, and hence square of length of line segment also less than or equal to square of arc length. Yes, now it is less than or equal to square of arc length. Let us observe the distance P to M and A to M from the figure. P to M, that is vertical component sin theta. First I am going to write sin theta in place of PM. So this is sin square theta. Next plus. Now AM square. Observe the figure. Since it is of 1 unit radius, A to M, from entire one, if you remove cos theta, you will get AM. So AM distance is nothing but 1 minus cos theta. So here you have to write 1 minus cos theta whole square less than or equal to theta square. And from this I can write already theta square, which is more compared to combination of sin square theta and 1 minus cos theta whole square. If I write only sin square theta, also that is less than or equal to theta square. And if I write 1 minus cos theta whole square, also less than or equal to theta square. So from these two, I can write sin theta, or applying square on both the sides, you will get mod sin theta less than or equal to modulus theta, and also applying modulus on both the sides, modulus 1 minus cos theta always less than or equal to modulus theta, and also you can write sin theta in between modulus minus theta modulus theta, and here I can write 1 minus cos theta, which is in between minus of modulus theta and modulus theta. So you got two results. One is sin theta, which is lying between minus modulus theta and modulus theta. Another result, 1 minus cos theta, also lying between minus modulus theta, modulus theta. So these two results are very, very helpful in calculus. We know just sin theta and cos theta lies between -1 to +1. And solving calculus problems, they are very helpful those who are appearing JEE mains examination. So remember that sin theta and 1 minus cos theta both lies between minus modulus theta and modulus theta. The students, those who are watching my videos, please like, share and subscribe this channel. Thank you so much.